MSX is the name of a standardized home computer architecture, first announced by Microsoft on June 16, 1983, conceived by Kazuhiko Nishi, then Vice President at Microsoft Japan and Director at ASCII Corporation. It is said that Microsoft led the project as an attempt to create unified standards among hardware makers. Despite Microsoft's involvement, the MSX-based machines were seldom released in the United States, but were popular mostly in Japan, the Middle East, Brazil, the Soviet Union, the Netherlands, Spain, and to a lesser extent, several other European countries. It is difficult to estimate how many MSX computers were sold worldwide, but eventually 5 million MSX-based units were sold in Japan alone. Before the appearance and great success of Nintendo's family computer, MSX was the platform for which major Japanese game studios, such as Konami and Hudson Soft, produced video game titles. The Metal Gear series, for example, was originally written for MSX hardware. History. In the 1980s, Japan was in the midst of an economic awakening. Large Japanese electronics firms might have been successful in the early computer market had they made a concerted effort in the late 1970s. Their combined design and manufacturing power could have allowed them to produce competitive machines, but they initially ignored the home computer market and appeared hesitant to do business in a market where no industry standard existed. Nishi proposed MSX as an attempt to create a single industry standard for home computers. Inspired by the success of VHS as a standard for video cassette recorders, many Japanese electronic manufacturers along with Gold Star, Philips and Spectre Video built and promoted MSX computers. Any piece of hardware or software with the MSX logo on it was compatible with MSX products of other manufacturers. In particular, the expansion cartridge form and function were part of the standard. Any MSX expansion or game cartridge would work in any MSX computer. Nishi's standard was built around the Spectre Video SV328 computer. The standard consisted primarily of several off-the-shelf parts. The main CPU was a 3.58 MHz Zilog Z80, the graphics chip a Texas Instruments TMS9918 with 16 KB of dedicated VRAM, the sound and partial I/O support was provided by the i3-8910 chip manufactured by General Instrument, and an Intel 8255 programmable peripheral interface chip was used for the parallel I/O such as the keyboard. This was a choice of components that was shared by many other home computers and games consoles of the period, such as the ColecoVision home computer, and the Sega SG-1000 video game system. To reduce overall system cost, many MSX models used a custom IC known as MSX Engine, which integrated glue logic, 8255 PPI, YM2149 compatible sound chip and more, sometimes even the Z80 CPU. However, almost all MSX systems used a professional keyboard instead of a chiclet keyboard, driving the price up again. Consequently, these components alongside Microsoft's MSX Basic made the MSX a competitive, though somewhat expensive, home computer package. Debut. On June 27, 1983, the date considered the birthday of the MSX standard, the MSX was formally announced during a press conference, and a slew of big Japanese firms declared their plans to introduce machines. The Japanese companies avoided the intensely competitive U.S. home computer market, which was in the throes of a Commodore-led price war. Only Spectre Video and Yamaha briefly marketed MSX machines in the U.S. Spectre Video's MSX enjoyed very little success, and Yamaha's CX-5M model, built to interface with various types of MIDI equipment, was billed more as a digital music tool than a standard personal computer. Images of a similar model, the Yamaha CX-5M II/128, adoption. During the 1980s, Europe became the largest computer games market in the world, and the extremely popular Commodore 64, Atari 8-bit, and Sinclair ZX Spectrum computers dominated. By the time the MSX was launched in Europe, several more popular 8-bit home computers had also arrived, and it was far too late to capture the extremely crowded European 8-bit computer market. A problem for some game software developers was that the method by which MSX1 computers addressed their video RAM could be quite slow compared to systems that gave direct access to the video memory. This, and the fact that the completely different features the MSX1's video chip had to compensate for the slower video access were not efficiently used while porting software, made the MSX1 appear slower when running ported games. Some minor compatibility issues also plagued ported Spectrum games. For example, the Toshiba HX10 machine was unable to read certain key combinations at the same time, preventing the Spectrum standard of Q, A, O, P steering, whereas machines by other manufacturers worked fine. Later games tended to use the MSX1 joystick port or used MSX's official arrow keys and spacebar, or offered the option to choose other keys with which to control the program, solving the problem. A larger problem was that the designers of the MSX standard bank switching protocol did not prescribe to hardware manufacturers in which banks the cartridges and, more importantly, the RAM should be found. Moreover, the MSX's BIOS did not provide this information either, thus requiring programmers to implement complex routines to find these resources. Often programmers assumed that the RAM and cartridges would be available at a default bank switch location. In reality, some systems had their RAM or cartridge slot, not at the default location, but at another bank switch location. In those cases, programs failed to run because they only saw 32 KB of the available memory, instead of the full 64 KB that almost all MSX1 machines offered. All other mainstream MSX1 machines offered at least the full 64 KB of RAM, with a very few exceptions, such as some early Philips MSX1 models. Evolution: MSX spawned 4 generations, MSX, MSX2, MSX2 Plus, and MSX Turbo R. The first 3 were 8-bit computers based on the Z80 microprocessor, while the MSX Turbo R was based on an enhanced Zilog Z800 known as the R800. The MSX Turbo R was introduced in 1990 but was unsuccessful due to a lack of support and the rise in popularity of the by then well-established IBM PC-compatible market. Production of the Turbo R ended in 1993 when Panasonic decided to focus on release of 3DO. The MSX3 was scheduled for market in 1990. Delays in the development of its VDPA then named V9978 on the pre-release spec sheets caused Yamaha to miss its time-to-market deadline. In its place, an improved MSX2 Plus was released as the MSX Turbo R. Features of the newer 800 processor such as DMA and 24-bit addressing were disabled. The VDP was eventually delivered 2 years after its planned deadline, by which time the market had moved on. In an attempt to reduce its financial loss, Yamaha stripped nearly all V9958 compatibility and marketed the resulting V9990 EVDP3 as a video chipset for PC VGA graphic cards, with moderate success. Sony also employed the V7040 RGB encoder chip on many other products. MSX-FAN magazine also mentions the then impressive power of the V9990, being able to compete with much more expensive hardware such as the Sharp X68000. Impact: MSX never became the worldwide standard that its makers had envisioned, mainly because it never took off in the US and the UK. However, in Japan, South Korea, Argentina, and Brazil, MSX was the paramount home computer system of the 1980s. It was also quite popular in continental Europe, especially in the Netherlands and Spain. Classrooms full of networked Yamaha MSX were used for teaching informatics in school in some Arab countries, the Soviet Union, and Cuba, where they were wildly popular in all government education schools and centers. As the Cuban government made a move to modernize their studies of computer systems, in 1985, higher pedagogical institutes and some schools of pre-university education were supplied with Toshiba and Panasonic MSX systems with resident MSX basic language, popularly known as intelligent keyboards. Once they proved useful, the Minister of Education continued the process installing similar systems throughout all secondary centers and finalized it in elementary schools, adult education institutions and newly nationwide formed a Euro-OE Computer and Electronic Youth Clubs a Euro in 1987. Forming the computer clubs allowed the Cuban government to interest and educate the common citizen in computer subjects, since selling these systems, or any other personal private computer, to public was banned. In the 1980s, ASCII Computers started the production of the first Arabic version of MSX computers. They started producing a Yamaha AX100 and a few other models, including MSX2 and MSX2 Plus. The most popular and affordable model within Arab countries of the Persian Gulf was the ASCII MSX AX170. They were also the first to Arabize BASIC and the MSX logo. Al-Alamiya produced other common models, including AX100, AX123, AX150, AX170, AH200, AX200, AX230, AX235, AX250, AX330, AX350i, AX352, AX355, AX370, AX500, AX550, AX660, and AX990. The only MSX console with a Famicom game slot in the MSX computer is AX330. The user can switch between MSX and Famicom modes by pressing a button on the back of the computer. The other variants, which are compatible with the Sega Mega Drive, are the AX660 and AX990. Many MSX computers were used during the 1980s in Eastern European countries as a tool for subtitling pirated films on VHS, or Betamax cassettes. The MSX computers were used for their simplicity and ability to display prepared titles in real time as superimposed text on mastering tapes. The MSX arrived in Argentina in late 1984. The most popular model was the Talent MSX DPC-200, based on the Daewoo MSX DPC-200. Other models were the Spectre Video 728 and the SVI Zapress, with a 3.5 inches built-in drive. Later on came the Toshiba and some very few Gradient models from Brazil. In the late 1987, Talent presented the MSX2 TPC-310 a turbo in the Argentine market. A turbo was just a cliché, not referred for MSX2 Plus, also based on Daewoo design. The MSX was a highly successful computer in Argentina as Commodore 64, thanks to Impulse Educational at national level. The MSX logo language was used deeply in the schools. MSX II Plus never entered into production in Argentina and MSX ceased in 1990. In total, 9 million MSX computers were sold in Japan alone, making it relatively popular but still not the global standard it was intended to be. In comparison with rival 8-bit computers, the Commodore 64 sold 17 million units worldwide in its lifetime, the Apple II sold 6 million units, the ZX Spectrum over 5 million units, the Atari 8-bit sold at least 4 million units, the Amstrad CPC sold 3 million units, and the Tandy TRS-80 Model 1 sold 250,000 units. One MSX2 machine was even launched into space on board of a Russian Mir spacecraft. One professional broadcast video workstation based on Sony Hitbit HBF 900 MSX2 computer and HBIF 900 AV creator was also very known in Japan. Name: the exact meaning of the MSX abbreviation remains a matter of debate. At the time, most people seem to agree it meant Microsoft Extended, referring to the built-in Microsoft Extended BASIC, specifically adapted by Microsoft for the MSX system. Another suggested source for the abbreviation was Matsushita Sony. However, according to Kazuhiko Nishi, MSX could also stand for Machines with Software Exchangeability. In 1985, Kazuhiko Nishi told that he named MSX after the MX missile. The MSX DOS disk operating system had internal software mechanisms much like CP/M, but had a file system compatible with MS-DOS, and its user commands were also similar to early MS-DOS versions. In this way, Microsoft could promote MSX for home use while promoting MS-DOS-based personal computers in office environments. Similar systems, The system MSX most closely resembled was the Spectre Video SV328 home computer. This led to a new and short-lived kind of software cracking, converting. Since the MSX games were unplayable on the SV328 computer, SV328 crackers developed a method of modifying the games to make them work on the SV328. In most cases this included downloading the MSX BIOS to the SV328 from tape or floppy disk. Spectre Video later launched the SV728 which completely adhered to the MSX standard. The Sega SG-1000, the Mimotech MTX and the ColecoVision all have many similarities with the MSX1 standard, but none are really compatible with it. Porting games between those systems is somewhat easy. It was also very common to port games from the ZX Spectrum to the MSX, since both have the same CPU. The Spectrum 128 had the same sound chip, and the ZX Spectrum's graphic mode could be easily emulated on the MSX's Screen 2 mode. Localization: by default MSX machine has hard-coded character set and keyboard return scan code handling algorithm. While MSX in overall has full application software compatibility, at the firmware level coupled with its hardware level, due to minor hardware differences, replacement of the BIOS with another from different PC may render incorrect scan code translations and thus incorrect behavior of the keyboard subsystem for the application software. In 2011 AGE Labs introduced Language Pack firmware, aiming for making single models supporting several localizations. By default installed into GR8BIT instead of the Kanji ROM, it allows changing character set and keyboard layout at the machine start between Japanese, Russian, international and Portuguese locales, as well as changing locales during machine operation using new introduced basic command lang. Selected locale setting is stored into the unused RTCN-VRAM memory space. Revivals, 2001 revival. In 2001, Kazuhiko Nishi initiated a MSX revival around an official MSX emulator called MSX-PLAY. This is the only official MSX emulator as all MSX copyrights are maintained by the MSX Association. In 2004, a Dutch company BASICS announced they had become the representatives of MSX Association in Europe, being the English contact for any questions regarding the MSX trademarks, copyrights, and licensing. On October 17, 2006, BASICS launched WOOMB.net, a website selling MSX games in English and other languages, with a selection of 14 games. In Japan, game sales began earlier, through Project Egg. WOOMB.net was the English counterpart of this and other Japanese services offered by D4 Enterprise, which also announced in August 2006 the launch of a new MSX2-compatible system called the One-Chip MSX, a system based on an Ultracyclone EP1C12Q240C8 FPGA. The One-Chip MSX is similar in concept to the C1, a Commodore 64 clone also built on the basis of a single FPGA chip. The new MSX system is housed in a box made out of transparent blue plastic, and can be used with a standard monitor and a PC keyboard. It has two MSX cartridge slots and supports the audio extensions MSX Music and SCC+. A SDMMC flashcard can be used as an external storage medium, emulating a disk drive and can be used to boot MSX-DOS. Due to its VHDL programmable hardware, it is possible to give the device new hardware extensions simply by running a reconfiguration program under MSX-DOS. The One-Chip MSX also has two USB connectors that can be used after adding some supporting VHDL code. On June 7, 2008, the MSX Resource Center Foundation reported that the MSX trademark had moved from MSX Association to the MSX Licensing Corporation, referring to a Benelux trademark register page of MSX, which names the MSX Licensing Corporation as entitled entity till October 28, 2013. At that time, the website of the MSX Licensing Corporation that they linked to a source, had a text saying "We are planning to revitalize MSX, the innovative computer platform" on it. However, the website was later changed to contain only the logo of ITNY and Partners, and a link to ITNY and Partners English and Japanese websites, and has no mention of the MSX Licensing Corporation at all. On June 26, 2008, BASICS reported on their website's front page that they are no longer the representative of MSX Association, due to being unable to achieve their goals of bringing about the commercial MSX revival beyond the Japanese borders, and the transfer of the MSX trademark from MSX Association to MSX Licensing Corporation, and no outlook on any progress in the Western one-chip MSX project anytime soon. As a result of this, WOOMB.net is taken offline as well, with its website redirecting to the BASICS website, until a solution free of MSX Association's contributions has been completed. According to their post, they will cooperate with D4 Enterprise and the MSX Licensing Corporation in one or more retro gaming-related projects. On July 4, 2008, MSX Association's European Contact website, which states to be the only official contact place for MSX Association in Europe, reports that the MSX trademark and copyright has been under the MSX Licensing Corporation holding ever since 1983. It explains that MSX Association, chaired by Dr. Kazuhiko Nishi, is the operational division of MSX Licensing Corporation which manages the trademarks, logo and copyrights for MSX. According to the same article, D4 Enterprise refused to pay royalties to MSX Association for the use of ASCII Artists Factory's work in one-chip MSX and the software licenses in Project Egg. Thus they deal with Kazuhiko Nishi directly through the MSX Licensing Corporation. The article mentions as well the ASCII MSX System 3, on which the one-chip MSX is based. On July 5, 2008, the MSX Association's Europe website posted an announcement reporting that D4 Enterprise was selling the one-chip MSX illegally. In the same post it is stated that BASICS no longer is their representative in Europe, due to BASICS cutting off their relationship. 2011 revival. In 2011, AGE Labs announced the launch of a MSX kit called GR8BIT, the do-it-yourself computer for learning purposes, which was licensed by the MSX Licensing Corporation. The kit is priced at $499 and includes all necessary components to assemble a working MSX2 compatible computer, except for an ATX chassis, power supply, floppy drive, hard disk, PS/2 keyboard and monitor. It also comes with assembly and operational manuals and a supplement compiled from vendor and community support. 2014 revival. Some of Korean forum members who made Zemix Neo created a new version of MSX called Mini IQ 3000 QT, which has similar features to the IQ 2000. It is based on one-chip MSX but has some special features like scanline generator and multi-language support. The scanline generator generates scan lines to show the MSX screen with better quality. It supports 2 languages at the same time. Normally it shows Korean font and working as Korean version of MSX, but when pressing the del key while booting, it changes to Japanese mode. Even though the default mode is Korean, the default font allocation table is Japanese, as it shows Japanese characters when executing Japanese version software. Franchises established on the MSX. The most popular and famous MSX games were written by Japanese software houses such as Konami and Hudson Soft. Several popular video game franchises were initially established on the MSX: Celeste and Zanuck, Bomberman, Penguin Adventure, Eggland, Metal Gear, Parodius, Puyo Puyo. Others got various installments on the MSX, including some titles unique to the system or largely reworked versions of games on other formats: Castlevania, Contra, Dragon Quest, Dragon Slayer, Final Fantasy, Gradius, R-Type, Wizardry, Kshak, is, manufacturers. MSX, Spectre Video, Philips, Aula Lamia, Sony, Sanyo, Mitsubishi, Toshiba, Hitachi, National, Panasonic, Canon, Casio, Pioneer, Fujitsu General, Yamaha, JVC, Yashica Kyocera, Gold Star, Samsung Fena, Daewoo Yino, Gradient, Sharp Epcom, Talent. MSX2, Philips, Sony, Sanyo, Mitsubishi, Victor, National, Panasonic, Canon, Yamaha, ACVSCL, DDX, Daewoo Yino, NTT, Talent. MSX2 Plus, Sony, Sanyo, Panasonic, ACVSCL, DDX. MSX Turbo R, Panasonic. Do-it-yourself MSX, AGE Labs, Note clones or unlicensed equipment. System specifications, MSX. Processor, Zilog Z80A running at 3.58 MHz, ROM, 32 KB, BIOS, MSX Basic v1.0. RAM, 8 KB minimum, most machines provided either 32 or 64 KB. Machines with 128 KB exist. Video display processor, Texas Instruments TMS9918 family, video RAM, 16 KB, text modes, 40A, 24 and 32A, 24, resolution, 256A, 192. In reality there are just 15 color tints available, because, just like Sinclair Spectrum, there are 2 codes for black. Unlike the Spectrum, however, one of the blacks is actually transparent, so the MSX video picture could be overlaid on another video signal, for example one from a video disc. Sprites, 32, 1 color, max 4 per horizontal line. Sound chip, General Instrument i3-8910, MSX2, processor, Zilog Z80A running at 3.58 MHz, ROM, 48 KB, BIOS plus extended BIOS, MSX Basic v2.0 or v2.1, Disk ROM, MSX Audio BIOS. RAM, 64 KB minimum, commonly 128 KB in Europe, 64 KB on Japanese computers. Machines with up to 512 KB were made, memory mapped. Video display processor, Yamaha V9938 supports all MSX video modes plus, increased video RAM, 128 KB, new text mode, 80A, 24, new bitmapped video modes without the attribute clash of MSX-A1, new resolutions, 512A, 212 and 256A, 212. Increased number of, and more advanced sprites, 32, 16 colors, max 8 per horizontal line, hardware acceleration for copy, line, fill, etc. Interlacing to double vertical resolution, a vertical scroll register, vertical and horizontal display offset register. Sound chip, Yamaha YM2149, clock chip, Rykoa P5C01. 3.5 in floppy disk drive is common, MSX2 Plus. Only officially released in Japan, processor, Zilog Z80 compatible running at 3.58 MHz, ROM, 64 KB, BIOS plus extended BIOS, MSX Basic v3.0, Disk ROM, CAN Basic, Kanji ROM. RAM, commonly 64 KB, memory mapped. Video display processor, Yamaha V9958. All of MSX2's specifications plus, the minimal video RAM is now 128 KB. Up to 192 kilobytes is supported. A new 256A, 212 YJK video mode with 19,268 simultaneous colors, a new 256A, 212 mixed YJK RGB video mode with 12,499 simultaneous colors, a horizontal scroll register. Sound chip, Yamaha YM2149, optional sound chip, Yamaha YM2413, clock chip or P5C01, 3.5 in floppy disk drive is very common, MSX Turbo R, only released in Japan, processor, R800 and Zilog Z80A compatible, R800 running at 7.16 MHz, Zilog Z80A compatible running at 3.58 MHz for backward compatibility. ROM, 96 KB, BIOS plus extended BIOS, MSX Basic v4.0, Disk ROM, CAN Basic, Kanji ROM, firmware. RAM, 256 KB or 512 KB, memory mapped. Additionally 16 KB or 32 KB of SRAM. Video display processor, Yamaha V9958. So the same capabilities as MSX2 Plus, sound chip, Yamaha YM2149, sound chip, Yamaha YM2413, sound chip, PCM, 8-bit single-channel, 16 kHz max using BIOS routines. Microphone built-in. Sound chip, MIDI in out, clock chip, 3.5 in floppy disk drive. Peripherals, keyboard. Keyboard is a functionally separate unit which could be connected by non-multiplexed and multiplexed interfaces. Multiplexed keyboard units feature additional data direction line, allowing sending scan line number to the keyboard using same data lines used for return scan code, decreasing overall number of wires between keyboard and machine. Non-multiplexed interfaces usually used for internal keyboards. Multiplexed interfaces used for external keyboards. Keyboard is organized as a matrix with maximum 11 input lines and 8 output lines, accounting for maximum 88 keys. Each scan line is regularly queried to identify the state of the keys on the line. Query speed is identified by the system interrupt frequency. Such organization allows system to sense state of each key, not exhibiting notorious problem with 8042 microcontroller-based keyboards when pressing several keys simultaneously generates wrong input characters, or renders inability to sense the press of more keys. Due to keyboard scan being controlled by the system interrupts, it is one of the troubleshooting hints when MSX machine does not display any image to press caps key and see if respective LED toggles. If it does not toggle, system is deemed suffering more serious problem than just lack of image on the screen. In 2009 Gamil Karimov designed the adapter board to connect PS/2 keyboard to the multiplexed MSX keyboard interface. The firmware embedded into its ASCII chip was tailored for Daewoo PC machine. In 2011 AGE Labs embedded PS/2 keyboard controller unit, based on microchip microcontroller, into its GR8BIT do-it-yourself machine. Its firmware is developed to directly convert PS/2 scan codes to the MSX keyboard scan codes, thus is fully transparent to the applications, allowing using designed controller unit with different MSX-compatible machines and for different localization setups. Cartridges. MSX standard requires at least one cartridge slot, most MSX models have two. These slots are interchangeable, so in most cases it makes no difference in which slot a cartridge is inserted. A physical connector is a 50-pin, standard 2.54 ohm pitch edge connector. Using these cartridge slots, a wide variety of peripherals could be connected. Regular game cartridges are about the size of an audio cassette. Despite their higher cost, this was a popular format due to its reliability and ease of use. Around 1985, Hudson Soft released the credit card size B card, which was meant as a cheaper and more convenient alternative to ROM cartridges. But it was a commercial failure, and very few titles were released on the format. Source files for development of the MSX cartridges are available from AGE Labs for Eagle, floppy disk drives. MSX systems generally did not have a built-in disk drive, so games were published mainly on cartridge and cassette tape. Sony created a battery-backed RAM cartridge, the HBI-55 data cartridge, for a few computers of their 8-bit line of MSX systems, that could be used to store programs or data as an alternative to cassette tapes. Floppy disk drives were available for MSX, however, in the form of a cartridge containing the disk interface electronics and a BIOS extension ROM, connected to an external case with the drive. In South America, many of these systems used a 5.25 in floppy disk drive, but in Europe, mostly the 3.5 in drives were popular. In Japan, some MSX1 systems included a built-in 3.5 inches disk drive, like Panasonic's CF3000. In Europe, a whole range of Philips MSX2 systems NMS 8230, 8235, 8245, 8250 and up features either 360 or 720 kb 3.5 inches floppy drives. In 1985, the MSX2 was released, which systems often included a built-in 3.5 inches disk drive too, and consequently the popular media for games and other software shifted to floppy disks. The MSX 3.5 inches floppy disks are directly compatible with MS-DOS. Like MSDISA 1, MSX disks under MSX-DISA 1 have no support for subdirectories. In September 2012, AGE Labs extended the standard by including support for 1.44 MB 3.5 Euro format. The 1.44 MB diskette size goes in two configurations, standard and compatible. MSX Audio, Yamaha Y8950, commercially released as Panasonic MSX Audio FSCA1, Philips, Music Module NMS1205, Toshiba, MSX FM Synthesizer Unit HX-MU900. 9 channels FM or 6 channels FM plus 5 drums. YM3526 compatible. ADPCM record and play, with hardware acceleration, can be upgraded to 256 KB of sample RAM. MSX Music, Yamaha YM2413, also known as MSX Music, Panasonic, FM Pack, Zemina, Music Box, Checkmark, FM Stereo Pack, DDX, FMX, Technobytes, FM Sound Stereo. 9 channels FM or 6 channels FM plus 5 drums, 15 preset instruments, 1 custom, built-in as new standard on MSX2 Plus and MSX Turbo are computers. Emulation. MSX computers are emulated on many platforms today. Early on, most MSX emulators are based on the code of the Pioneer FMSX, a portable MSX emulator by Marat Fazulin, but many emulators removed Fazulin's Z80 emulation code entirely in later versions to avoid legal problems, as at the time FMSX wasn't free software. Somewhat later, FMSX source code became free to use for non-profit use. However, a license was still required for commercial use. On December 31, 2013, the Windows version of FMSX 3.7 was released, free for anyone to use. The official MSX emulator MSX-PLAY is produced by the MSX Association, of which the inventor of the MSX standard, Kazuhiko Nishi, is the president. As of version 0.146U, MESS currently supports 90% of all MSX versions. Virtual Console. In February 2007, Nintendo of Japan announced that MSX games will be available for the Wii's Virtual Console emulator. It was confirmed that the games would cost 700 Wii points and will become available from the middle of 2007. It will also become available for the Wii U on December 25, 2013. Ultimately 13 games, mainly Konami titles, for the Wii plus 1 for the Wii U were released for the service in Japan only. See also, History of computing hardware, List of MSX-compatible computers, List of MSX games, Moonsund, SimOS, Zemix, Canon V20, References. External links, MSX at DMOZ, the MSX Resource Center, the MSX Files, MSX Pro.